All right, we are wrapping up our unit on statistics. This is section 112. The start thinking part says Terrence has a home supply store where he sells snow shovels. He's trying to gain information to help him plan on how many shovels to have available for sale. He looks at the connection between three different variables and with snow shovel sales. And you can see those in graph 1, graph 2, and graph 3. You can see in graph 1, it seems like the points are just spread all over the place. Graph 2, there is a general upward trend, and the points are pretty packed together except for those two random ones at the bottom. We'll talk about those in a second. And then graph 3 has a general upward trend, but the points are pretty spread out. A says which variable seems to be the most useful for him to monitor to determine how many shovels to have available. Explain your reasoning. While both graph 2 and graph 3 have a general upward trend, and you can kind of see there is somewhat of a line going up, it felt like variable 2 was the best one because they're more packed together, meaning the correlation between them, the correlation coefficient would be closer to 1 just by looking at it. B says one variable is daily snowfall, one is hot chocolate sales, and one is sandwich sales. Determine which is variable 1, 2, and 3. Be ready to justify your reasoning. I said variable 1 was sandwich sales, and the reason why is there's not really much of a connection between the snow shovel sales and the sandwich sales. So as one increases, the other one kind of just jumps all over the place, and that makes sense for comparing those two variables. Variable 2 I thought was much more likely to be snowfall, because as snowfall increases, you would think there would be more snow shovels sold. And number 3, that one I thought was hot chocolate sales, because while you end up going over and having more hot chocolate sold at the same time that you're having more snow shovels sold. They're not directly connected to one another. There's some kind of connection that's connecting both of them, but you can see that there is that connection, but it's still pretty spread out. Now C says, does there appear to be a correlation between snow shovels and variable 3, which we said was hot chocolate? Does this likely mean that variable 3 is causing the change in the snow shovel sales? Be ready to justify. And the answer is yes, there does seem to be a connection between them, but no, I do not think that one is causing the other. I don't think that snow shovel sales are causing there to be more hot chocolate sales, nor hot chocolate sales are causing there to be more of the snow shovel. So what we have here is we have two things that are connected, but they're actually connected by something else, and that's the weather. The colder it gets and the more snow, usually people need to buy snow shovels, and people are usually wanting something nice and warm to drink, which could be hot chocolate. So the main point of this lesson is to make sure that you understand just because things are connected in some way, you really want to be careful when you're trying to use the word caused by or causation. It's actually very challenging to prove that something causes something else. So in this case, they are correlated. They are connected in some way, hot chocolate sales and snow shovel. We're not exactly sure. We can see that as one increases, the other one increases. So there's some kind of connection, but we're not going to say that one is causing the other. Another thing is that we have something called positive correlation and negative. If one increases and the other one does, or one decreases and the other one decreases, then we call that a positive correlation. For example, as hot chocolate sales increase, then snow shovel sales are increasing as well. That would be a positive because it's up, up. And when you look at the line of best fit, it would have a positive slope. Same thing is true for daily snowfall and snow shovel sales. As one increases, the other one increases. As one decreases, the other one decreases. Now, getting to those two random points in graph 2, I asked the students why they thought that we could have a bunch of snow, but we sold no snow shovels. And a student said, well, if we got enough snow, then the roads are closed down, or they just are snowed into their house and they can't go buy snow shovels. And that is correct. So that is what I was thinking when I made those points on there. So once again, you are free to use the word correlation. The two seem to be correlated, related in some way, but going over and using the word caused by or causation, you have to be very, very careful. Realistically, when I was talking to the statistics teacher, she said you needed to have a random trial to be able to go and say that something is causation, or if it is just like something is caused by something else because of science, like the height of an object is kind of dependent on the original upward velocity that it's thrown at. Well, those we know by science, one thing is causing the other thing. So we are going to be talking a little bit more about correlation and causation. This next application here says Pedro changes the amount of time that he leaves his plants in the sun each week and records how many inches that is grown during that period. The graph to the right shows the results. As you can see, there does seem to be some kind of correlation. Does there seem to be a correlation between the two? Yes. As one increases, the other increases. It does seem like there's some kind of connection. We're not exactly sure what that connection is. It is also a positive correlation, as I said, because one is increasing and the other one is increasing. And we could also look at the correlation coefficient. You can see that they're pretty closely packed together along what you would think where the line of best fit would be. So this one, these are pretty well, there's a pretty good correlation coefficient close to 1. Is this guaranteed to be a causal relationship? And the answer is no. Well, very likely, because we have science that says you have photosynthesis and the more sun, usually it's going to be growing more. There are other factors that we have to think about, such as, did he put different soil in? Did he put fertilizer in there? Is he getting more water? So there's other things. And while we can say there is a high correlation between these two things, you got to be careful when you're trying to use the word causation. I would probably say these are highly correlated with a positive correlation. Let's take a look at the next one. This one right here says Meredith records how long she takes to wash her hands over multiple hand washing sessions during a 1-week period. She also records how much water entered the sink during that. The data is organized into a scatter plot. It says, does there seem to be a relationship between the amount of time washing your hands and the amount of water that enters the sink? And the answer is yes. As one increases, the other one increases. They seem to be falling somewhat in a line, so there does seem to be a positive correlation between those. Is this likely a causal relationship? And explain. Now you could kind of justify this in both ways, but I say yes, because the water that is coming out of a certain rate, and it will directly affect the amount of water in the sink. So the amount of time that it is going will directly determine how much water is in the sink. And if you students say, what happens if she poured a water bottle in there or didn't turn on the faucet as high, or you could argue that as well. But I'm saying if there's anything that I'm going to say is causal, then this would be it. Next, what do you notice about the correlation coefficient of the scatter plot? So since these are falling perfectly in line and it's got a positive slope, I would say that the correlation coefficient R equals 1. And that's just going perfectly in line. So this one, the one that we were most tempted to say is one is causing the other one, that is going to have a correlation coefficient of 1. So what we learn is you can kind of look at your correlation coefficient. If it's getting really close to 1 or -1, you can be pretty confident in saying that things are very connected in some way. There is a high correlation between the two. If it is really spread out, or as it gets more and more spread out, there's probably some kind of connection, but it's probably not a super strong correlation. This next one here is bringing up some real world examples of things that a lot of people like to argue one is causing the other, and I don't think they've done like a randomized study on this. So what I did was I gave students these 2 different scenarios, and they had to argue and explain why this might be causing it, and then an alternate possibility. So one of them is talking about Airbnbs in Flagstaff, the number as they increased, and the increase in home price. And the first thing is when we look at that, you could see that there does seem to be some kind of correlation between the two. As one increases, the other increases as well. And students had to justify why this connection might be happening, if that was a true connection. And one of them is less houses available, so supply and demand causes prices to go up. Another student said, well, now if you have houses that are being run as businesses, people are going to be buying them as houses as well, and they just become worth more. It's no longer just a place for you to live, it's a place for you to make money. And that is a good justification. So maybe the more Airbnbs in a town, it is going to go over and cause the prices to rise. But another possibility is just inflation. Prices go up. Also, other people leaving other places. For example, a lot of people left California in the past decade and came to Arizona. And these people are coming after selling their house in California. They have so much cash to be able to buy a house. They can usually sell their house in California, pay it off, and then just with the profits, buy a house outright in Arizona and just live free and clear without having to pay any payments. So that could be a reason as well. Just more people are moving to Arizona, and Flagstaff is a very tempting place to live. Now, on this other graph, I forgot to switch the axes. The bottom one is actually supposed to be the number of campers in the season in thousands, and the other one is the number of forest fires. So those should be switched. Imagine that they're being switched. So some people might say that the number of people who are camping is causing forest fires. And you could justify that. You could say all those people are camping. When I go camping, I love having a campfire, roasting some marshmallows. And the more times that you have fires out there, the more likelihood there's going to be forest fires. So you could justify that one is causing the other. But then again, you could say that there's drought, and maybe drought is the issue, or the super thick forests are causing more forest fires, or lightning, more crazy storms due to climate change, and you have more crazy storms with lightning, and it's lighting trees on fire. So the main point of this lesson is just to say you can go over and say that there is a correlation between two things. You're basically saying there's a connection between them. But when you start pushing towards saying something is causing the other thing, you really should be doing studies for that. Usually scatter plots are just going to be showing like a relationship between two things, and it's not really used to be able to say, oh, this thing is causing this other thing. You usually have to do a more in-depth study. Now let's go ahead and go over the homework. Um, It says, give an example of each of the following with certain conditions. Be ready to share and justify your answers in class. So two variables that have a causal relationship. One causes the other. And when you're looking at that, I thought an example could be the number of minutes that an item is in an oven at 350 degrees and the temperature of that food until it gets to 350. You could pretty comfortably say that the temperature is causing and the time inside of the oven is causing the food to heat up. Now, answers will vary, and usually whatever you give me should be based on science, because you are not going to be doing a randomized study to prove that something is causing something else. Two variables that have a strong relationship, but such that there may be another variable that could be causing a change. So hour studying and grades on the test. So yeah, most likely the more you study, the grades are going to be going up, but there might be some other variable that's going over and affecting the test scores. There's many different possible things that could be the difficulty of the test. If the teacher goes over and gives a good review, there's many different variables here. And then two variables that may be related, but only weakly. I would say the number of bike rides and the number of ice creams eaten. My family sometimes likes to take a bike ride and go get ice cream, but we don't do that all the time. So just generally, if more people are getting out, maybe more people are going to be eating ice creams, but we can't say that one of them is causing the other, and there's probably a pretty weak relationship between those two things. Next, Liana records the number of times she goes out to eat each week and the amount of money she spends in general on her credit card each month. She plots the data on the scatter plot, and the graph has a correlation coefficient of 0.89. What does the correlation coefficient mean for the two variables? It looks like the two are pretty well connected. There's a pretty good correlation. It's getting close to that 1 number. Does this indicate causation between the two variables? Be sure to explain. No, there could be other costs that are increasing her credit card bills as well. So one causing the other, we would have to do a higher level study to find out what else she's buying, and maybe she's going out to eat, but she's going to really cheap places, and it's actually saving money because she's not cooking at home. So we don't know for sure, but usually when you start going out more often, you are going to be spending more money. The next one, Peter is adjusting the price of an item he's selling on Amazon. Over a month, he records the list price and the number of items sold. The graph, he graphs the data as a scatter plot. The scatter plot has a correlation coefficient of negative 0.73. Explain why the correlation coefficient is negative. And the reason why is we said if two things increase at the same time, it's a positive correlation, or if they both decrease. But if one increases and the other decreases, that's going to be a negative correlation. And here, as the price increases, the sales are going to be dropping. So that is going to be a negative correlation. Next one, Tamara records the time each student spends brushing their teeth each day and the number of cavities they have over a 3-year period. What would you estimate the correlation coefficient to be for the situation? Explain your reasoning for the actual number and why you chose it to be positive or negative. I picked negative 0.8 and negative because as the time increases that you're brushing, the number of cavities is probably going to decrease. And I said 0.8 because there's probably a pretty close connection, a good relationship between brushing your teeth and the number of cavities you have. The next one says a car dealership is recording data on the number of car sales they make and the number of TV ads that they have each month. They graph the data on a scatter plot with car sales on the vertical axis and number of TV ads on the horizontal axis. The line of best fit is y equals 2.6x plus 8. What does the slope mean? And what this means is the number of cars sold over the number of ads. So for every one extra ad, they can estimate that they're going to get another 2.6 cars sold. Now, that's weird to say 2.6 cars, but we're just running with what the slope is. What does the y-intercept mean? It means that if they have 0 ads, it's estimated that they will still sell 8 cars. And then our last one, a scatter plot has 5 data points and a correlation coefficient of 1. List the 5 possible residuals for the data points. Well, if it is a correlation coefficient of 1, that means the data points are perfectly on the line of best fit, which means the distance from the points to the line of best fit is going to be nothing. It means that the actual is going to be exactly what the estimated is, which means that all of them better be zeros. There is no difference between the actual and the estimated. That's how we got 0, 0, 0, 0, and 0. All right, hopefully that made sense. Thanks for watching.